Hey guys, what's up everyone? How are you people doing? Hoping that all of you guys are doing good and taking very good care of yourself. Welcome back to today's session. So today is going to be for CBSE 10th 6th session of electricity, wherein we are going to be talking about the heating effect of electric current. So before we get started, let me introduce myself, guys. My name is Anoop. I'm a master teacher of science here with Vedantu. A very warm welcome to all of you guys out there. Hoping that all of you guys are doing good once again. So without any further ado, let us get started with today's session, wherein we'll be talking about the heating effect of electric current. But before we get started, we're going to start off this session also with a very interesting quote, and the quote is this, guys: if it is important to you, you will find a way. If it is not, you will find an excuse. So that's as simple as that, guys. If you really want to do something, no matter what, you will always find a way to do it. But if you really don't want to do it, you'll find all the excuses out there in the world to make sure that you don't get to do it. So that is the way of life. So if you really want to succeed, stop making excuses and start finding a way to do things that you want to do. Alright, guys, with that said, let us get started with today's session. So we have already completed till the resistance in series and parallel. We've done that. Today we'll be talking about the heating effect of electric current. Before we get started, guys, let me just tell you one thing, that you had actually studied about heating effect of electric current in your 7th grade. I don't know if you guys remember it. In your 6th grade, you had learned about magnetic effect of electric current, and in your 7th grade, heating effect of electric current, and in your 8th grade, you also looked into the chemical effects of electric current as well. So this is basically a continuation of that, but then here you'll be learning about how to calculate the heat generated also. So these are the things that will be added on in this particular year of your 10th grade. Alright, guys, so anyways, let us get started. But before we get started, guys, I had also given you a homework in the last session, that is resistance in parallel. First of all, a big round of applause to all those guys who gave the answer in the comment section below. So the question was this: find the equivalence of resistance of two resistors of 10 ohms connected in parallel. So that is the question. You're supposed to find out the word equivalent resistance. So if you remember the formula, 1 by R equivalent in a parallel connection is 1 by R1 plus 1 by R2. Here in this case, both of them have a resistance of 10 ohms. So it will be 1 by 10 plus 1 by 10. That makes it 10 into 10 whole divided by 10 plus 10, which is 100 divided by 20, which would give you 5 ohms. As simple as that. So here are some of the superstars who gave the right answer. We have Kavya, Krishna, Dharmender, Pravina, Parth, Lata Munde, Shubham, and also Ganesh. Congratulations, guys. Well done. Keep up the good work. I hope to see more such answers from you people. If you want your name to be here in the next session, make sure to go, go down and put it down in the comment section below. Whatever the homework is, make sure that you do it as soon as you can. All right. With that said, guys, let us get started with today's session without wasting any more time. So here's the thing, guys. I don't know if you ever noticed it. Like when you put your phone to charge, after some time it gets heated up. I don't know if you've ever noticed it. Like next time, try to check it out. If you've ever connected a adapter of your, let's say your laptop or your phone, if you keep it connected, what happens is that it gets heated up. Now we're going to talk about what is the reason why this heat is produced. What could be the possible reason why this heat is produced. It's not like you're going to go take your phone and put it under a stove. No, that is not what is happening. But still, there's heat produced. So how is that happening? We're going to talk about that. Now, to understand this, guys, we have to go back into a topic that you've already studied before, that is resistance. We saw that what is resistance? It's nothing but the obstruction offered to the flow of charge. So when the current is, when the charge is flowing, there is other atoms present inside the conductor. So what happens is that it collides with those atoms, loses some energy, and basically slows down. So that is what is called as resistance. The obstruction offered is what is called as resistance. Now, here's the thing, guys. When these charges are flowing, when they collide with the other atoms, they are losing energy. And that loss of energy is basically in the form of heat. So whatever energy they have, they are losing it in the form of heat. It is getting converted to heat energy. That is what is happening over here. That's how they are losing that energy, and that's how they are slowing down. So what this means is that if the resistance is more, then the heat energy produced would also be more. More is the resistance, more would be the heat produced. What we're going to do in today's session is try to calculate how much, or how do we calculate this heat produced in a conductor. Let's talk about that. So to understand this, guys, we'll take a simple example. Let's take a simple conductor which has ions and electrons connected to a battery, and you also have a key. So you see this, as soon as you turn on, like as soon as you see this, the switch is off in this case. As soon as you turn on the switch, what happens? There's a potential difference created. The battery would basically create a potential difference, so the charges would start flowing from one end to the other. Awesome. So far so good. Now, here's the thing, guys. Whatever is the work done by the battery, that is equal to the energy gained by the charges. So basically, more is the potential difference that you create, more would be the faster would be the rate of flow of charge. So basically, that is what it is. So you see that more would be the flow of charge if in case you were to create a greater potential difference. So work done by the battery is equal to the energy gained by the charges. And as the charges are flowing, more is the flow of charge, more would be the collision, so the heat produced would also be greater. So whatever is the energy gained by the charges, that is also equal to the energy lost in the form of heat, because they are also colliding with the other atoms. So what I'm going to do is that we have already seen in the last session that in the previous session, the first session, we saw that basically potential difference is nothing but work done on a unit charge, right? So in this case, energy is equal to work done by the battery, which is equal to what I can write this as in place of work done. I'm going to substitute it as V into Q. Very simple. So work done is equal to V. I'm just rearranging this equation to get work done. So what I found out is that energy gained by the charges is equal to the work done by the battery, which is equal to basically the potential difference or the voltage into the flow of charge, or charge in other words. So yes, guys, I can write that energy is equal to basically V into Q. That is what we just saw right now. So energy is equal to V into Q. Now, instead of Q, to remove Q, what I'm going to do is that I'm going to divide it and multiply it by T. Now here the thing is that the equation's value does not change because T gets cancelled, and you can, again it'll be 1. So the value of the equation is not changing at all. But we know that Q by T, basically the flow of current is the rate. What is current? Current is nothing but rate of flow of charge. So Q by T is what? Q by T is nothing but I. So in place of Q by T, I'm going to represent it as I. So what I'm going to get is basically this equation where E is equal to V into the current into the time. That's all. Into time, that is the time around, like as long as the the time to which the circuit is turned on, or time along which the current is flowing. So for how much of a time the current is flowing. Now the thing is this, guys, whatever is the energy gained by the charge is also the energy lost by heat. So what I'm going to do is that because basically energy gained by the charge is also equal to the energy lost in the form of heat. So in place of E, I'll write it as H, because again, whatever energy the charge is gaining, it is also lost in the form of heat. So H is equal to V into I into T. Very simple. All right, so I'll get this as H into V into H is equal to V into I into T, where H is nothing but heat generated. So in other words, heat generated in a conductor is basically equal to the voltage into the current flowing through the circuit into the time that it is given by. As simple as that. Now, according to Ohm's law, we've also seen that what V is equal to I into R. We already know that V is equal to I into R according to Ohm's law. So what we can do is that substitute this value in place of V. So what do you get? H is equal to I into R into I into T. Very simple. So I into I gets multiplied. So you get this I square R T. Very simple. Okay. So this, my friends, is the formula for heat generated inside a circuit. You can either use this equation. Again, if the current is, if you do not know the resistance, then you can use this equation. If in case you know the current and the resistance, then you can use this equation. Ultimately, both of these equations are perfectly correct. So this is how you're going to get, or by using this formula, you can get the heat generated inside a particular circuit. Now, the unit of this is basically in terms, you have to write it in terms of joules. So this is called as the Joules Law of Heating. So this basic formula that you see right now is called as the Joules Law of Heating, where H, or heat generated, is equal to the square of the current into the resistance offered by the circuit into the time taken. As simple as that. So according to the Joules Law of Heating, what exactly did we see so far? Heat produced in a conductor is directly proportional to three things. One is the square of the current that is passing through the conductor. It is also equal to the resistance of the given circuit, and also proportional to the time for which the current flows. So however long the current is flowing, That is what is basically the Joules law of heating. So three things once again, guys: square of the current for the given resistance, whatever is the fixed value of resistance, how much of a current is passing through it, the square of that into the it's proportional to the resistance offered by the circuit, and also the time taken, or the time through which the current would basically flow. As simple as that. So with that, guys, we'll solve some interesting questions right now. The questions are very interesting. These are different types of questions, so hopefully you guys would enjoy doing these questions. But yes, guys, be prepared and make sure to keep a pen and paper ready. Pause the video, take a piece of paper and pen, and start writing the answer as soon as you see the question. All right, so here's the first question, guys. The reason for heat to be generated in a current carrying conductor is four options: voltage across the conductor, the material of the conductor, collision between the charges inside the conductor, or metals are good conductors of heat. What is the reason that there is heat generated in a current carrying conductor? Whatever is the answer, write down in the comment section below, A, B, C, or D. However, the answer to this question is actually option number C, guys, because like I told you already, it is because of the collision of the particles. So when the charges are flowing, those charges would collide with the atoms that is present inside the conductor, and that is what produces the heat energy. So that is the answer for the first question, guys. Moving on to the second question. Here we go. A current of 5 ampere is passed through a conductor of 12 ohms for 2 minutes. Calculate the amount of heat produced. Is it 10 kilojoules, 36 kilojoules, 3.6 kilojoules, or 1 kilojoules? The question is actually pretty simple, but then you have to look at the unit as well. First of all, write down the formula. So H is equal to I square RT, that is the formula. Now in this case, guys, first of all, make sure that you convert the minutes into seconds. So 2 minutes in terms of seconds is 2 into 60. So that gives me 120 seconds, right? It will give you 120 seconds. So H is equal to, what is the current flowing through the conductor? It's 5 amperes. So 5 square into the resistance is 12 ohms into 120. So it's basically equal to 25 into 12 into 120, which would be, if you calculate it, you will get it as 36,000 joules. Now, if you want to convert it to kilojoules, that is also fine. So divided by 1000 to give, because 1 kilojoule is equal to 1000 joules. So divided by 1000, you'll get it as 36 kilojoules. Simple, guys. That is the answer. So the heat generated or heat produced in this particular circuit is basically 36 kilojoules. As simple as that. So that is the answer for the second question, guys. Alright, guys, moving on to the third question. This is the third question. Two irons P and Q have resistance 10 ohms and 20 ohms respectively. Both are connected to a voltage source of 220 volts for 3 minutes. Find the ratio of heat generated in P and Q. So you're supposed to find out what is the heat generated in P and Q, and then find out the ratio of this. So the options are 1:2, 2:1, 1:4, or 4:1. It's actually a straightforward question, but then there's a lot of calculation involved. So I'm going to try to do it as simple as possible. Okay, so first of all, write down all the given data. So R1 is given as 10 ohms. R2 is given as 20 ohms. Voltage is 220 volt. And the time taken is basically 3 minutes. So if you convert that 3 minutes to seconds, so 3 into 60, that'll give you 180 seconds. So these are the values that is given to you. First of all, remember the formula, that is heat generated is basically equal to, in this case, V into I into T. That is a formula that we know of. So first of all, find out the current flowing through R1 and R2. So how will you find that out? V is equal to I into R. So I is basically equal to, V is equal to I into R. So I is equal to R by V. So V is equal to, okay, so not, sorry guys, so V is equal to IR. So if you rearrange the equation, you'll get it as V by R, sorry. So it'll be V by R. So V is, for the first one, so I'll take it as I1 as 220 divided by, what is the resistance? It's 10 ohms, so it'll be 22 amperes. So for the first one, it's 22 amperes. For I2, it'll be V by R2. This is R1, this is R2. So that'll be 220 divided by 20. So 0, and it'll be 11 amperes. So that is what you're going to get. You're going to get the current as 22 amperes and 11 amperes. Now to find out what is the, put it in the equation, you'll get the answer. For the first one, it'll be basically, I'll take it as H1. H1 is equal to voltage for both the circuits, for both the conductor, like it's connected to the same battery, so it's 220 volt itself, into the current flowing through the conductor as 22, into the time taken is 180. So if you calculate it, you will get a very big value, somewhere around 8,71,000, something like that. So if you calculate it, you get something like that. So 8,71,200, something like that, something around this value you're going to get. And if you talk about H2, if you calculate that, that is also 220 into 11 into 180. So this one, if you calculate, you'll get to something around 4,35,600. That is what you're gonna get. So I know the calculation, it takes a little longer. That's why I have to directly write the answer. So if you find out the ratio, that is H1 divided by H2. If you put on the values, that is okay. So there's no space for me to write. So I'm going to remove this part, guys. The first part off, I'm going to remove that. So if you calculate this value, if you just substitute or divide both of them, that is H1 divided by H2, H1 divided by H2, you will get it as how much? 8,71,200 divided by 4,35,600. You will get the answer to be 2/1. So that is the answer, guys. The answer to this question is basically 2:1. That will be the answer for this question. I know the calculation seems a little too tough. I mean, it's a little big. It's time consuming. That's all. It's not that it's tough. It's just simple multiplication. But then it takes a little longer. That's why I directly wrote the answers around. All right. Anyways, that is the answer for this question, guys. It is 2:1. The ratio is 2:1. Moving on to the next question, guys. Here's the next one. If the current flowing through a fixed resistor is halved, the heat produced in it will become 1/4, 1/2, double, or 4 times. What happens to the heat produced in a conductor if the current is reduced to half of it? So first of all, write down the formula, guys. That is H is equal to I square RT. That is a formula that you already know of. So in this case, they're asking you, what if you were to decrease the current by half? So the new current, I'll take it as I dash, would be equal to 1/2 of the original I. So I'll just substitute the value over here. So basically it'll be H is equal to 1/2 the whole square into I square into R into T, because it's square, right? So I'm going to square the value. So what will I get? It'll be 1/4 I square RT. Simple as that, guys. So if in case the current is reduced by half, then the heat reduces by, or the heat produced in the circuit reduces by 1/4 of it. So the answer to this question, guys, would be 1/4. As simple as that. All right, guys. Moving on to the fifth question. Again, I want all of you guys to try out these questions and write it down in the comment section below. Here's the last question, which is asked in your 2011 board exams. The question goes like this: two devices of rating 44 watts and 220 volt and 111 watt and 220 watts are connected in a series. The combination is connected across a 440 volt main, the fuse of which two devices are likely to burn when the switch is on. So you're supposed to find out which one would burn faster if in case you were to connect it to connected across the mains around 440 watts. So that is the question. So your options are 44 watt. The first one, is it 44 watt and 220 volt, or is it 11 watt and 220 volt, or both of these, or the data is not sufficient for you to get the answer for this question. So this is the question, guys. You're supposed to find out the heat. Again, which of these would be able to withstand, or which of these would get fused? That is the question. So you're supposed to find that out. So let's try to do this question. It's actually a pretty simple question. For the first one, let's take I'll take the 11 watt to be the first one. So first one, I know the power is 11 watt and the voltage is basically 220 volt. Now here's the thing, guys. First thing, find out the resistance. Find out the resistance of the circuit. So the formula is basically power is equal to V square by R. This is the formula, all right? V square by R. This is one of the, there are three formulas. This is one of the formulas of power. So if you rearrange the equation, you'll get R resistance equal to, one second, resistance is equal to V square by W. Very simple, V square by W. So what is V for the first one? R, to find out the resistance, is 220 the whole square divided by 11. So if you find the value, you'll get somewhere around 4,400, I guess. If I'm not wrong, it's around 4,400 ohms. Yeah, it's around 4,400 ohms. For the second one, to find out the resistance, once again, for this, the power is 44 watts and the voltage is 220 volts. Again, same thing. So R is equal to 220 the whole square divided by 44. You would get the answer to something around 1,100 ohms. Yes, guys, because like I told you, calculation takes a little longer, so I have to write it down directly. So you get the answer as 4,400 ohms and 1,100 ohms. So I'm going to write this value separately because there's a lot of calculation involved. So I'm just going to write this separately on the side, and I'm going to erase all of this. All right, so here we go. So all right, so I'm going to erase all of this and write down the values separately. So I found out the resistance to be what? For the first one, it's 4,400 ohms, and for the second one, it is basically that is 44 watts, 220 volt would give you a resistance of 1,100 ohms. Awesome. So you found out the resistance. Now what you do is that basically find out the current. Now that you found out the resistance, find out the current flowing through the circuit. It's a series connection, so basically the current flowing to the circuit would be the same. So current formula is I is equal to V by R. So in series connection, basically the resistance, you're going to add it up. So R equivalent is equal to R1 plus R2, which would basically be 5,500 ohms. That is the resistance. So 220 divided by 5,500, you will get the answer as 0.08 ampere. So the current flowing through the circuit is 0.08 ampere. So you found out the current, you have also found out the resistance. Now all you have to do is find out the potential difference across the first one of the first device as well as the second device. So potential difference, that is V for the first one, is basically again I into R. So the first one, I into R1, so 0.08 into the resistance is 4,400, and for the second one also V2 is equal to, that is the potential difference across the second device, is 0.08 into the resistance in the second one is 1,100. So you'll get the answer to be, if you calculate it, you'll get the answer as 352 volts, and you'll get this as around 88 volts. Just do the calculation, guys. I might be wrong in the calculation. Just check the calculation, but nonetheless, somewhere this is the answer. Somewhere it's going to be around like this. So the answer to this question, guys, the question is which of these is most likely to fuse, and the answer to that question is actually option number A, or basically the first, that is the 11 volt and the 220 11 watt and the 220 volt would be the one to fuse, because of the fact that 220 is basically, if the if the voltage exceeds 220, then there's a high chance that you might you might cause a short circuit. So the answer to this question would be option number A, guys. That will be the one which would fuse first, because the current is the voltage is exceeding 220 volts, which means the current flowing through the circuit would also be more, which means that this could lead to a short circuit. So the answer to this question would be option number B, guys. That is 11 watt and 220 volt. So the only new thing that you're looking over here is basically the formula of power. So power, once again, guys, power, that is power is the unit of power is watt, so that is why you're writing it as W. So watt is equal to basically V square divided by R. So that is the voltage square divided by the resistance would give you the power. So just remember this formula and you'll be able to give the answer. And this is a board question as well, so if you're able to solve it, hats off, people. So that is it for today. That is all I had to do that is all we have for today's session. But this is the homework, guys. As always, I would expect you guys to give me the answer to this homework in the comment section below. The question is this: a water heater produces heat of 200 joules in 20 seconds. If the heater draws 1 ampere current, find the resistance of the heating coil. So you're supposed to find the resistance. They've given you the heat produced, they've given you the time taken, they've given you the current also. You just have to find out the resistance of that particular circuit. As simple as that. So that is it from my side, guys. Thank you for joining today's session. Hopefully you guys learned something new out of today's session, and if you did enjoy today's session, leave a like and subscribe to the channel. If in case you want to reach out to me personally, you can also reach out to me at anoop.manoharan@vedantu.com. So until the next time we meet, take care of yourselves, stay safe, guys. This is Anoop signing off for the night. Take care, guys. Bye bye. Take care.